So we are going to start on lesson 322 or 322 on problem 3. Actually, I'm going to start on 371. 370 just says, what do you know about the number 1 with your team, brainstorm, all that good stuff. Now, in some of this, I'm going to show you the calculator on the computer. I'm going to do the best I can kind of to move it around so you can see it. Not real sure how good you're going to be able to see it, but it'll be better than nothing, I guess. So 371, it says, Mr. Wonder claims that anything divided by itself equals 1 as long as you do not divide by 0. Okay, that's true because, as we learned a long time ago, anything divided by itself is 1 except for 0, which in case it becomes undefined because it's 0 over a 0, and a 0 is under the line, so it's undefined. Now, Mr. Wonder states that 16x divided by 16x equals 1 if x is not 0. What is his hypothesis and his conclusion? Well, his hypothesis is 16x divided by 16x, anything divided by itself is 1. His conclusion is that it equals 1. Alright, is he correct? I would say yes. It says that is a statement true. Yes, it is. Justify your conclusion. The easiest way I would say to justify it is to say, so we're on part B now. I would say, well, if x equals 5, so 16 times 5 over 16 times 5, that's going to equal, let's see, 0, 3, 5, 80 over 80, which equals 1 if you do it in the calculator. That shouldn't be all that hard for you. All of us should be able to do that at this point. Now C says, why can't it be 0? Well, because 0 over 0, or 16 times 0 over 16 times 0 equals 0 over 0. We have a 0 under the line, so it's undefined. Okay, again, it's one of my dumb ways of remembering stuff. It works for me. If it doesn't work for you, that's fine. Alright, part D says, next he considers x minus 3 over x minus 3. Does this equal 1? What value of x must be excluded from this fraction? Okay, so what he's saying is, because anything divided by itself equals 1, then that's a true statement. We just proved that with this work up here. Now, what number makes it untrue, makes it false? Look at your denominator right here. Okay, what would make this equal to 0? So I'm just going to simply say, when does x minus 3 equal 0? Simply solve for the equation. So x equals 3. Really, x cannot equal 3. So the answer to this is equals 1 if x does not equal 3. Because if it equaled 3, then we would have 3 minus 3 over 3 minus 3. And again, 0 over 0, which relates back to this right here. And it's undefined. Alright, create your own rational expression, algebraic fraction that equals 1. Y'all can do that. Whatever, that's pretty easy. Okay, now, for part F, it says, Mr. Wonder also says that when you multiply any number by 1, the number stays the same. For example, he says that that the product below equals x over y. Is he correct? What he actually has in part F is z over z times x over y actually equals x over y. Well, anything times itself is what? Everybody should be saying anything times itself is itself, or anything times 1 is itself. Well, we know we've proved that this right here equals 1, so 1 times this equals that. Okay, we should be good on that. There's not a whole lot of hard part on that. All right, first part where you kind of need to use your calculator, 372. Okay, it says, use calculator to graph the function of 16x over 16x. Use the trace button to trace along the line and notice what happens at 0. Is the expression 16x over 16x equivalent to 1? I've already worked all these out, so we'll kind of do it a little bit different. I'll show you what I put in for all our y equals is, see if I can do this so that you can see it. Hopefully you'll be able to see this, but you can see where right here, I'm going to move this over a little bit so we can see it a little bit better, hopefully. Alright, you can see y1 I have 16x over 16x. Now when I go to graph, you see a whole bunch of different lines when this gets finished. Remember, we kind of talked about it some in class before, but just because you can do it one way doesn't mean you have to do it. So I'm going to go ahead and I'm going to go to my table. Actually, I'm going to hit enter to pause this, maybe. No, it's going to go ahead and graph the whole thing. So let's let it finish graphing. Kind of remember what these look like because we're going to come back. Alright, so if I go to my table, now if you notice my delta table, so the way I do that, second table set, okay, the way that I did all this, delta table, I put it at 0.5, and I just put it at -3, you can put it at -5, whatever you want to put it at. That's just kind of where I started it at. Notice you got an error message on y1, which is 16x over 16x. That error message is because 16 times 0 is 0, so it's undefined. So everywhere where you see an undefined through here, it is because it is undefined. So if you go back and you look, this starts on the next problem, but we'll kind of talk about it here in just a second. But everywhere you look, so does 16x over 16x equal 1? Yes, it always equals 1 except for 0 where it is undefined. Alright, now that's 372. That's all good. 373, okay? 373, it states, with your team, compare and contrast, okay? F1, F2, F3, F4. First, visualize and make a quick sketch of what you imagine the graph of each will look like, okay? Do that. Use your calculator to do the graph. You're going to have your calculator on the ACT, okay? Discuss your sketches with the rest of your class, okay? You should be able to talk about that, kind of figure it out. Next, use your calculators to graph each rational function and adjust your sketches if you need it. So if they weren't right, then redo it. D, use the trace function or the table in your graphing calculator to find the location of the hole in each of the graphs and describe their similarities and differences. What you should see is that any of these that are identical on the top and the bottom, okay, they're identical on the top and the bottom, so the numerator and the denominator are the same. So if they're identical, then they're going to be 1. If they are just opposites. So, for example, right here, if you're looking either right here, y3, which happens to be y2 or f of 2 right here, so 2x minus 3 over x minus 2x, or 3 minus 2x. This one right here, notice all they did was they switched these around, okay? And this one, which is f of 3, they didn't switch them around. They just changed the sign. Okay, so now if you go to your second table, okay, this is your first one where they're identical on the top and the bottom. This is where they simply switch the sign. So y3, we can go back to it. Or actually, I can just do it this way. And you can see what it equals. Okay, so if you're looking right here or right here, they move these around, had the same sign. Okay, it becomes -1. Now for y4, I think that's f of 3. Notice that they simply switch the signs. Okay, you have a asymptote. Okay, you're going to have an asymptote. Now for f of 4, again, you'll have another asymptote. Now we'll look at the graph of them real quick. All right, there's all your graphs. There's an asymptote where it's undefined, undefined, you're undefined. There's a blue line under here where you're undefined, and somewhere else it's undefined. But as you can see, it's not all that hard to kind of find where it is. All right, so now we're going to go back, kind of work through that with the calculator. Hopefully that worked out. We'll see. All right, 374. Okay, so we're going to skip down here. We did 373. Actually, both of these we did on the calc. Later. So now we're going to do 374. All right, it says, use what you know about the number 1 to simplify each expression below if possible. State any values of the variable that would make the denominator 0. So x squared over x squared. Well, we know that equals 1. Now, what would make that equal 0? So x squared equals 0. Again, as long as it's not 0, so x cannot equal 0. So your answer would be x squared over x squared equals 1 if x does not equal 0. So that's your A. All right, your B, you got x over x, you've got times x over x, and you've got x over 3. All right. What I call canceling out is really saying that this equals 1, this equals 1. So those cancel, x over 3. That is your final answer. That's what that simplifies to. And since you have a whole number and no variables on the bottom, it's always going to be, that's always going to be the case. It won't have one of these if x does not equal. Okay, that does not apply to this one. All right, so for C now. All right, you got x minus 2 over x minus 2 times x plus 5 over x minus 1. Now, looking at this, put parentheses around this and group them, okay? It'll help you. I know it's easy to see right now. Most of you are saying, okay, well, we can cancel these out. That becomes 1. And your answer winds up x plus 5, x minus 1, if x does not equal what? You should be saying 1, because x minus 1 equals 0, add 1, x equals 1, or it cannot equal 1. But by grouping that, it'll make it easier in the long run. These cancel each other out or equal 1, the -2 and the -2. Okay. All right, now, starting to run out of room. D. All right, you got h times k over h. Okay, cancels each other out. So this equals h times k, or just hk over 1, which is the same thing as saying hk. We don't have to state that hk over 1. All right, so F. All right, F, we got 2m minus 5 and m plus 6. Some of you right now are thinking FOIL. Okay, just wait before you do that, okay? Let's see if there's anything that we can cancel out before we get to that. Then we got m plus 6 over 3m plus 1, or times 3m plus 1. That's over that. Look at this. Is this the same as this? Is this the same as this? Nope. Is this the same as this? Yes. Well, they can cancel each other out. Now I've got 2m minus 5 over 3m plus 1. Now we need to take that denominator, 3m plus 1. It cannot equal 0. So we set it equal to 0, minus 1, minus 1. So now we got 3m equals negative 1 divided by 3. M cannot equal negative 1/3. Alright, now G. Okay, G is, you're going to have to pull back on some of your Algebra 1 stuff that Miss Johnson or Miss Umberger or whoever you had for Algebra 1 taught you. You're going to have to pull some of that information. Okay, 6 times n minus 2 squared over 3 times n minus 2. Alright, let's simplify this as much as we can. What does this break out to be? Well, it winds up being 6 times n minus 2 times n minus 2. That's squared, okay, 3n minus 2. Alright, well, cancel. Okay, a lot of you will stop right there. But what can this section do? Okay, that can simplify. What's 6 divided by 3? 2n minus 2. Now you're finished. You can go another step. You can say 2n minus 4 if you want to, but you don't have to because you would factor out a 2 and wind back right from here to here. These are equivalent. Alright, now H. This is one of those problems that I would have given in Algebra 1 class just really to test to see if they knew what they were doing or if they were just kind of waiting for me to put the answer on the board, so to speak. Okay? Because a lot of them are going to say this equals 4x minus 1 because they're going to cancel this out. Well, what does this cancel out to be? It cancels out to be 1 over 1. You've got to have, if that 1 is in the numerator, it has to stay. It'd be different if it would have canceled everything out in the denominator. Okay? That's completely different because that would be divided by 1. Well, this is 1 divided by something, so it's a very, very small number. Now, going back to looking at G just real quick, is there anything in the denominator? No. So, don't have to do the if x does not equal. Okay. This has a variable in the denominator, so I'll have to say 4x minus 1 cannot equal 0, so I add 1 plus 1, 4x equals 1, divided by 4, divided by 4, x does not equal 1/4. Alright, does that make sense? Hopefully, because I can't answer questions because I'm not there. Hopefully you can figure it out. If not, ask one of the other teachers that are in there, Sub, Coach King, Miss Cherry, Miss Johnson. Ask somebody, send me a note on Remind, some way, figure it out. All of y'all are juniors and seniors at this point, you should be able to figure it out. Alright, 375. Mr. Wonder now tries to simplify 4x and 4 plus x divided by x, okay? Mr. Wonder thinks that since x over x equals 1, then 4x over x equals 4. Is he correct? Substitute 3 values for x to justify your answer. So what he's saying is 4x over x, does that equal 4? That's the question he has. So we're going to substitute in 2. So 4 times 2 over 2, 8 over 2 equals 4. That's true. I'm not going to go through all 3, 4, ever how many they want you to substitute in. Okay, we know that as long as this does not equal 0, as long as x does not equal 0, then that is true. That simplifies. We should have been able to figure that out from problems above that. Alright, he also wonders if 4 plus x equals 5. So for part B, what he's saying is 4 plus x over x always equal 5. Alright, his logic is, well, x over x equals 1. 4 plus 1 is always 5. So what we're going to do is we're going to say x, well, what if x equals 2? 4 plus 2 over 2 equals 6 over 2, which equals 3. So was Mr. Wonder correct? No, he wasn't. Wasn't that hard, okay? All right, D is really where I want you to start kind of looking at it. I'm rolling through some paper. All right, on D, it says, which of the following expressions below simplified correctly? Okay, this is really going to help you with lesson 323 and really your college algebra. There's a lot of this in college algebra. Okay, x squared plus x plus 3 over x plus 3. Mr. Wonder is saying this should equal x squared. Okay. Well, can we count? Some of you are going to try to cancel that. Remember, this is grouped. Okay. So if it's grouped, you can't cancel it. But what we can do is we can snowflake this or factor this, ever how you want to do it. Okay. If you want to snowflake it, snowflake it. A times C is 3. You're going to have 1 here. You need the factors of 3. Factors of 3 are 1 and 3. That's only 1s. I may have wrote that wrong. No, I didn't. Okay, so can you factor it? Is there anything that's going to make that you can factor that? I'm going to cheat and go look at the answers. This is part D. As soon as I get back into my book. 322. Alright, you can't, there's no way to factor that, okay? You can use a quadratic equation, all that good stuff, but his thinking is this cancels, and it leaves you with just this, okay? That doesn't work. Alright, so you can't, it's not that easy. I wish it was. Life would be a lot easier and I'd be a lot better algebra teacher, but neither one of those is the case. Now, if you look at, that was 1, this is D2, okay, x plus 2, remember I told you to make sure you group those, x plus 3, remember I told you to make sure you group them, over x plus 3, now this whole group can cancel out, that equals x plus 2, and that is what Mr. Wonder was saying, okay? Now 376 is what he was, the correct way to do this one right here. Okay, 376, they want you to factor this, they want you to simplify it. Okay, so they give you x squared plus 6x plus 9 over x squared minus 9. Okay, snowflake the top, so I'm going to snowflake it real quick. Alright, I got 9, I got 6, I got 3 and 3, x and x. So x plus 3, x plus 3, that's the numerator. Okay, this you should recognize as a perfect square, difference of squares. So x plus 3, x minus 3. Now that cancels out and you're left with x plus 3 over x minus 3. For B, C, and D, you do it the same way. You just got to factor them. Okay, I'm not going to baby step walk you through it because that's pretty much the whole lesson. It's about a 25-minute lesson. So hopefully, the book says it should take you 50 minutes to do it. I explained it in 25. If you need more help, it's probably going to take you longer because I've been doing it for longer than you have. All right.